In the last video, we learned how to use trig ratio in order to determine side length. Today, we're going to carry that one step farther and learn how we can use trig ratios in order to determine angle measures. If we are given a trig ratio or its decimal equivalent, you can use what's called inverse trig to find the angle. I think about inverse trig as working backwards. So now we know this ratio, we want to work backwards in order to determine which angle it is that has this ratio. So for instance, in the first one where we're told that the sine of angle A is equal to 0.6, what we're really trying to determine is what angle is it that has that sine value that's equal to 0.6. In the second one, where we're told that the cosine of some mystery angle theta is equal to 3/4, again, what we're really trying to determine, what we want to find out here is what angle is it that has the cosine value that's going to be equal to 3/4. And in the last one, again, tangent of some mystery angle x is equal to 0.38. What we're really trying to determine here is what angle out there has a tangent value that's equal to 0.38. So again, we're trying to find angles here instead of knowing an angle and trying to find the side. Just like we used our calculator to find side lengths, we're going to use our calculator to find angle measures. This is going to work a little bit differently than it did for side lengths because what we're trying to find is a little bit different, but it's not hard. So number one, or in the second part of this, it says use your calculator to find the measure of angle A in each example below. Where necessary, round each angle to the nearest degree. So for the first one, I'm trying to determine which angle it is that has a tangent value that's equal to 4.3. I'm going to open up my calculator. I'm going to go into my scratch pad or a document. I'm always going to check the settings and make sure that I'm in degrees, and that's very, very important. I am, so I'm all good. And I'm going to go back to my trig functions. But what's different this time is if I knew my angle, I would go find the sine of that angle. I don't know my angle, so I want to work backwards. I want to do the second one, which is called sine inverse. Except I guess for this first example, I want to find inverse tangent or tangent inverse. I want to figure out which angle has a tangent value that's equal to 4.3. So again, since I don't know the angle, I'm going to use this inverse one to work backwards. So what I'm telling my calculator is which angle has a tangent value that's equal to 4.3. And according to my calculator, that's going to be about 77 degrees. In the second angle, or in the second example, I want to figure out or determine which angle has a sine value that's equal to 0.13. I don't know my angle, so I can't use sine. I have to go down here and use that inverse sine. So by using that inverse sine, I'm asking my calculator, please tell me which angle has a sine value that's equal to 0.13. And when rounded to the nearest degree, that's going to be 7. In the third example, I want to figure out which angle it is that has a cosine value that's equal to 1/2. So again, I'm going to use that inverse cosine because I'm telling my calculator, please, oh please tell me which angle it is that has a cosine value that's equal to 1/2. And that's exactly 60 degrees. And then for the last one, I want to determine which angle has a sine value that's equal to 0.89. So about 63 degrees. So if I go back now and fill these guys in, this angle here we said was about 77 degrees. This guy here was about 7 degrees. This guy here was exactly 60 degrees. And this guy here was about 63 degrees. All right, so let's go ahead and dig a little deeper and see if we can figure out how to apply that into solving some problems. The directions say to find the measure of theta in each triangle below. They want us to round our answer to the nearest degree. So just like what we did with the sides, we're going to have to determine which trig ratio is going to be appropriate to use for the problem that we've been given. So my hypotenuse, remember, is always directly across from the right angle. So the side whose length is 32 is the hypotenuse. Theta is the angle I've been given to work with, so the side opposite that is going to be the bottom side of my triangle. The adjacent leg is going to be the leg whose measure is 14. So in this particular example, what I've been given to work with is I've been given the adjacent side and the hypotenuse. I need to use the trig ratio that deals with adjacent and hypotenuse. So the big winner here is cosine. Cosine is the ratio between the adjacent leg and the hypotenuse. All right, so now I need to go fill in my values. My angle is theta, so the cosine of theta is equal to the ratio between the adjacent leg, 14, and the hypotenuse, which is 32. And now we're going to apply what we learned in the beginning part of this lesson. We want our calculator to figure out for us which angle has a cosine value that's equal to 14 over 32. So I'm going to use inverse cosine. I'm going to type in the fraction 14 over 32. And to the nearest degree, then, I find that my angle's measure is about 64 degrees. All right, so theta is about 64 degrees. Awesome. All right, and looking at that second example, I'm going to apply exactly the same strategy. In this particular case, my hypotenuse is going to be the bottom side of my triangle. The side opposite theta is going to be the 26, and the leg adjacent to theta is going to be the 18. So the pieces that I've been given to work with here are the adjacent side and the opposite side. Therefore, I need to use the trig ratio that deals with opposite and adjacent. So the big winner for this problem is the tangent ratio. Tangent is the opposite over the adjacent. So the tangent of which angle? Tangent of theta is the angle that I'm working with here. The opposite side, 26, over the adjacent side, 18. So again, I'm going to go grab my calculator. I'm going to type in inverse tangent. The fraction I want to take inverse tangent for is 26 over 18. And when rounded to the nearest degree, my angle is 55 degrees. All right, so like always, I want you to skip up to the top of the next page, fill in the key ideas and the important understandings, and then do examples 2 and 3, and we'll check your answers when you come back to class.